This phenomenon story begins in 1932 when two German scientists discovered that a photographic plate that is submerged in an acoustically driven water bath has become dark. Ultimately, the surprising observation led to the discovery of sonoluminescence, turning sound into light. Sonoluminescence is the phenomena of visible light being emitted from an acoustically driven bubble. The bubble that is driven by the sound waves in the fluid oscillates in a non-linear manner. The bubbles form when sound waves are sufficiently intense to induce a gaseous cavity. The process is called cavitation. In basic terms, cavitation is the violent tearing of a fluid which results in an air cavity being created. Initially, a vacuum bubble is created. However, due to the extremely low pressure of the bubble and the extremely high pressure, well, in comparison at least, of the water around, gases dissolved in the water quickly diffuse into the bubble, hence resulting in a bubble underwater that is filled with air. Usually, bubbles formed in this way are extremely unstable due to the differences in pressure. Even so, stable bubbles can be created in laboratories relatively easily these days. When these bubbles collapse extremely rapidly, the temperatures of collapse of a bubble reached are in a magnitude of thousands of Kelvin. Temperatures recorded have usually been between 6,000 and 20,000 Kelvin, hotter than the surface of the sun. The center of the bubble is thought to be the hottest. Along with the massive temperature produced, amazingly a light flash is also emitted. The light flashes from the bubbles are extremely short, less than 12 picoseconds long. For unknown reasons, the addition of a small amount of noble gas to the bubble contents increases the intensity of the emitted light dramatically. The phenomena has not yet been properly explained, however, all theoretical explanations have four major assumptions. 1. The bubble remains spherical. 2. The bubble's contents obey the ideal gas law. 3. The internal pressure remains uniform throughout the bubble. And 4. No evaporation or condensation occurs inside the bubble. The phenomena does not only occur in water but in many different fluids. Interestingly, a different method of creating a light flash from a bubble has been carried out by a group in California. These researchers filled a steel cylinder with phosphoric acid and ejected a bubble of xenon into the tube. Then they let the cylinder drop and the resultant shock collapsed the bubble in a brief flash. Analysis shows that this flash has a peak intensity of 100 watts and temperature of 10,200 Kelvin. Even in nature, the pistol shrimp uses sonoluminescence to its advantage when hunting prey by quickly snapping its claw, which produces a bubble that emits light upon its collapse. The speed and pressure of the bubble is enough to kill a small fish. So, there we go, sonoluminescence means you can create your very own star in a jar.